Okay, so you're back and you're ready for more chemical formula fun, and you're going to write more formulas, and we're going to get a little more complicated today, and we're going to start doing polyatomics, but you'll be fine and you'll be great. What you'll notice is these are called tertiary compounds. They're more complicated, and the reason why they're more complicated is because they have that polyatomic. And when you have a polyatomic, poly means more than one. So you have more than one atom, but it is an ion. And again, you want to remember that what that means is it has a charge. These are listed on your ion sheet. There's a few that you're being asked to memorize just because you don't have enough time to look every single one of these up. You need to know what nitrate is. You need to know what carbonate is, that kind of stuff. But that's what we're talking about. So these are things that are bonded together. And for whatever reason, they are not neutral, and they actually stick together and then they bond to other things. And when you're learning them, it kind of may seem like chaos because there's so many different ones, but there really is like rules. There is like a method to the madness. So I'm going to give you the rules just to kind of help you, because again, this is not a complete list. These are the ions we're using, but again, there's always more. So this just kind of helps you to understand where they come from. So the first one we're going to look at is actually the one that ends in 8. And the reason why we're going to look at the 8 one first is it is the most common form of the polyatomic. And an example of that would be chlorate. And if you look up chlorate, he's ClO3 negative 1. So if you look up that on your blue sheet, that's what it's called. Everything else is based off of the chlorate or the most common one, and it's named according to that. So this is the base. So like you'll see nitrate, sulfate, phosphate, chromate, dichromate. These are all the most commons. Perchlorate is one more oxygen than the most common form. And again, if we look at an example, it would be perchlorate if we're comparing it. And when you look at perchlorate, instead of having 3 oxygens, it has 4. So it's ClO4. It still is minus 1. And you can see here, this is the base, and we used the base, and we named it accordingly. If we go below it, you can kind of think what's going to happen next. If we went above it, we had an extra oxygen. Now we have one less. So now we're changing the ending, and what we're doing is we're taking the 8 off, and we're adding a nite, and now there's one less oxygen than the most common form. If we look on our blue sheet, an example of this is chlorite. And again, most common form has 3 oxygens. So if we have one less, we're ClO2. And again, we are still minus 1. And again, you're responsible for knowing this. On the test, we can ask you this. I can give you dichromate, and I could ask you what dichromite is. And if you know the rules, you can apply them. And that's what we're asking you to do. Do you understand where they're coming from? Anyone can memorize. Anyone can just recite things back. But we want to see, do you understand it? And this last one here it's kind of like 2 steps. So you will have already changed this ending. So it won't end in 8. It'll end in 8. And now we're additionally adding a prefix. So there's 2 less oxygens than the most common form. And the example of this one is hypochlorite. And that's ClO minus 1. And you can see it was both steps. We did ite, and then we did hypo. So you may just want to keep in mind that they follow the rules. When you're doing tertiary compounds, you just want to keep in mind that your cation is still first, anion is still second. And again, if there's only one polyatomic present, nothing changes. If there's more than one polyatomic, because it's big and complicated, you're going to put it in parentheses so that you kind of protect it from the other chemicals, and it just kind of helps you to see that, oh yeah, that is together. Again, like chlorates always ClO3. So if I have 2 chlorates, what I would do is I would put that in parentheses, and then I would put a little 2 after it. So what we're going to do is practice a couple of them. And what we're going to do is we're going to do the names and the formulas first, and then we'll talk about atoms and ions and stuff. So don't really worry about, we'll just do the one and then we'll come back for the other. Alright, so we're going to do 3 where we write the formulas, 3 where we write the names. Same steps, you just have to find them on your blue sheet. So you find sodium, which we dealt with yesterday, Na+1. Carbonate, again, you need to find this verbatim. What is carbonate? Not carbonite, not anything close. Carbonate, CO3 minus 2. Lowest common multiple is 2, and you're balancing again. So you say, how many sodiums do I need? I need 2 of them. How many carbonates do I need? I just need a carbonate. Now keep in mind, this carbonate, this CO3, that is a carbonate. So as long as you just write CO3, you only have 1 of them. You don't have 3 of them. The carbon and the 3 oxygens make the carbonate. And that's your final answer for sodium carbonate. Next guy is one of my favorite ones to say, just as cool, potassium permanganate. And it's actually a very pretty chemical as well. It's bright purple, and it stains a lot of things, but it's purple and it's pretty, so a lot of people like it. So same steps. Potassium is K+1. Permanganate, again, it's on the back. Find it verbatim. It's MnO4 minus 1. That means our lowest common multiple is 1. Everything's already balanced, so this guy is KMnO4, which is also fun to say, KMnO4. And that's your final answer for that one. Chromium 3 oxalate, it has the Roman numeral, so make sure you're careful. So when we look this up, it's going to be Cr+3. Oxalate is C2O4 minus 2. And our lowest common multiple is 6. So that means they're both going to need numbers because we need more than one of each. So we say, okay, we need 2 chromiums. Now, we're going to need more than one of the oxalate. So what we're going to do is we're going to put it in parentheses. So we're going to have C2O4 in parentheses, and then outside the parentheses is what we are going to put the number that we need, and this guy is a 3. And the reason we do this is if you don't, this is what it looks like. And we'll cross this out and say don't do this. So what it looks like is you need 43 oxygens, which is really unfortunate, which is not what we want at all. So this is what you don't want to do because we aren't using our Roman numerals. Plus, it doesn't really show you that there's a polyatomic in there, which we want to be aware of. All right, the last 3 here, we're going backwards. So we're going to find our names. So we look these guys up here. We have cobalt. Now, cobalt has a Roman numeral, so I'm going to leave some space and come back to that. And then if you look up, he's in parentheses, so he will be verbatim on the back, ASO4. And when you look him up, you should see arsenate. Now, we have to figure out what's cobalt's charge. So you refer to the other guy, you refer to arsenate. Each arsenate is -3, and there's 2 of him, which gives us a -6. Which means our lowest common multiple is 6. So this is where you refer to your cobalt and you say, okay, what times 3 is going to give me that 6? Whatever that is my charge. And then we go back and we fill it in. So you say, what times 3 will give me that? And we are hoping that you said cobalt 2. So again, if each cobalt has a +2 charge, there's 3 of them, we get a +6. Alright, next guy, we look up Cu, and that is copper. Copper can have a Roman numeral, so we're going to have to figure that out. And again, you know it's going to have a Roman numeral because you look it up on the your ion sheet, and wherever you look at it, it has a Roman numeral. So that's your indication that you have to do that Roman numeral. You look up SO4, it's on the back, it's going to be verbatim, and it's sulfate. And then again, we just have to figure out, what is this pesky copper? So we look at sulfate, sulfate's -2. There's only one of them. That means our lowest common multiple is 2. And again, you turn to your copper. Okay, I have 2 coppers. 2 times what is going to give me 2? That's going to give you your charge, and that means that this guy is a copper 1. And again, it's just simple algebra, but you do have to do it. You're welcome to write it out if you don't want to do it in your head, but you do need to be able to do it and do it reliably, or it can be pretty nasty on quizzes and tests. And the last guy that we're going to do for this section is this guy. So again, you have to be familiar with what is a polyatomic and what's not, which is why you need to study these. These are not something that you need to memorize, but you need to know, is Na by itself, or is it Na with H, or is it H with the SO4? Like, what's a polyatomic and what's not? And there's nothing else we can do other than becoming familiar with it to really pick them out. So that's just something that's expected of you to learn. So what you find out is Na is by itself, it's a metal, and then HSO4 is a polyatomic. When you know that, it's very easy to look up the name. When you don't, it can get very confusing. And for this guy, it's Na, which is sodium. And then again, you look on the back, find it completely HSO4, which is bisulfate. No Roman numerals, and you are brilliant.